The second type of a junction diode what we are discussing is a light emitting diode, in short LED. All of us know LED, everything has LED nowadays, starting from the torch in your phone to the torches the lights what we have in our houses, to street lights, to headlights of a car and vehicle. Everywhere we see LEDs, correct? Now LED, how does an LED work? Let's talk about that one. Now when we say LED, light emitting diode, the name only tells, light emitting diode. First what we have, it's a PN junction. It converts electrical energy into light energy, provided it is in a forward bias condition. Okay, and it will be in forward bias condition, it's not going to change. Fine. Now in a PN junction, take any PN junction, what we do, first we do forward bias. And the PN junction are heavily doped. Okay, extreme doping is going to happen. In the sense, the doping will be around 2 or 3%, sometimes even 4%. Remember, I told you in the beginning, doping is less than 1%. Here we are doing 3% doping. That means it's a heavy doping. Okay. Now, when we do heavy doping and under forward bias condition, we pass the current. And now, the PN junction, what's going to happen? The holes and electrons are going to combine. Correct? And once they combine, they release energy. That released energy comes out in a different form. Fair enough? So the depletion layer decreases. Correct? Once the depletion layer decreases, combination is going to occur. That means that energy gap, Eg, what we have, that comes out as light energy. Okay? Which is Hc by lambda. So what is lambda? Hc divided by Eg. This is going to give us what is the wavelength of the radiation which has been emitted by the PN junction. Okay. Now generally, silicon and germanium, if we use these two, they don't emit light. They start to vibrate. Okay. That crystal lattice is there, the lattice begins to vibrate. But we need light, correct? That's why we don't use silicon or germanium, we use different compounds. Like we use gallium arsenide. This gives out infrared. The TV remote, you have seen TV remote, and small LED will be there, no? That is a PN junction having gallium arsenide. The next one is gallium phosphide. This gives out red or green color. Have you seen those in Christmas light decoration? The red and green and pluk pluk pluk, it will be there. That has gallium phosphide. Okay. The next one we have gallium arsenic phosphide. Here this gives out red and yellow. This also you must have seen. Correct? All those temple and all, if you go, you will see different colored lights, correct? There we have these things. That means in the sense, these LEDs are used in many cases. Depending on what the need is, we are going to take that particular compound. Okay? Now that we are in the subject of what we need, let's talk about the uses of LED. Okay? The first one, we use these LEDs in burglar alarms. Okay, in all the alarms we use these LEDs. We use this in calculators and watches, digital watch, digital calculator. Everywhere we use these LEDs only. Next one, optical communication. Long distance optical communication, we generally use gallium arsenide. Okay, because gallium arsenide, it's infrared, correct? For long distance optical communication, we use this. We use LEDs in computers, come on. I don't have to explain this. Everyone knows we use LEDs in computer. Correct? The next one, video displays. Everywhere we use this. TV, big TV. They say OLED TV, that TV, this. It's all LED only. Okay, and also you must have seen outside when you go, big LED screens you will see. Everywhere. So all the display, video display. Traffic signals we use this one. And remote control also we use this one. So basically LEDs have a lot of advantage and lots of uses. Alright, let's understand the next type in the next video.